This question is taken from 2021 exam paper. It's question 4. And we are asked to use the formula cos 2a is equal to cos squared minus sine squared to find the value of cos theta. So we have to be a little bit clever here and a little bit creative. There is no point with these questions in trying to do what you've always done and hack away at it with formula. You have to be creative. So take a minute, and what I would do is I would draw out the triangle. So we have a triangle that we can draw out from this, and that triangle looks like this. So it's going to be sine of the angle here, and I actually don't like looking at that theta over 2. I think it's going to cause me problems later on down the line. So I'm going to be clever about it, and I'm going to say let x equal to theta over 2. And I'll bring it back at the end, but for now I'm going to call it x. So there's x, and I know that sine is the ratio of opposite over hypotenuse, so the opposite is going to be 1, and the hypotenuse is going to be root 5. The next thing that I want to do is I want to figure out what is cos in that triangle. So what is cos going to be? I could figure that out, because cos of the angle, which is going to be cos of x, is equal to adjacent over hypotenuse. Now, slight problem. I don't know what the adjacent is, but I could figure it out because it's a right angle triangle. The focus is on sides. If the focus is on sides, I'm using Pythagoras. So, using Pythagoras' theorem, I'm going to have root 5 squared is equal to 1 squared plus, let me just call it a for adjacent squared. A squared then is going to be 5 minus 1. A is equal to 2. That wasn't so hard. So just going through it, 5 minus 1 is 4. Square root of 4 is 2. So 2 is going to go there. So now instead of saying this generic kind of adjacent over hypotenuse, I can write it's 2 over root 5. Okay, the next thing that I can do is I can take this formula. They're telling me to take that formula. So I'm going to take cos 2x. Okay, so I'm going to write cos 2x is equal to cos squared of a, which is going to be cos squared of x, minus sine squared x. Okay, right. I actually know what cos is. Cos of x is, and I actually know what sine of x is. And what's more is actually I could technically write this as cos of x all squared minus sine of x all squared. And that's going to be equal to cos 2x. I know what cos x is. I know what it is. So I'm going to take out cos x and I'm going to replace it with 2 over root 5, and I'm going to square it. And be careful that you're putting it in brackets so that when you square it out, you don't make any silly errors. I know what sine of x is. Now remember, we said let theta over 2 be equal to the sine of x, or the theta over 2 be equal to x. So this is sine of x. So I can fill that in here instead of sine of x. So that's going to be 1 all over root 5 squared. If I do that, I'm going to have 4 all over 5 minus 1 all over 5. Cos 2x is equal to 4/5 minus 1/5. If you have 4 of them and you take away one of them, you're left with 3. So 3/5 is equal to cos of 2x. X, if we think back, we paused it for a minute. I said hold that, hold the x, hold the theta over 2, and let's call it x for a minute. I put it back in, and I'm going to have cos of 2, and then it's going to be x, which is actually theta over 2, is equal to 3/5. 2 times theta over 2 is theta. We're left with cos of theta is equal to 3/5. So it wasn't about rote learning anything. It wasn't about hacking away with the formula from the books. It was about creativity, taking a step back, thinking about what you can say about sine, using the tools Or you introduce a new parameter, meaning you say let x equal to theta over 2. Acknowledge the parts of the question that you don't like the look of, set them aside if you can, and do that early on, and the question became so much nicer to work with rather than that fraction. So be clever about it, be creative about it, and you will get there on those unseen questions.